I would like to thank Dyson sir and NIT Trichy to provide me with this opportunity to research and give a presentation on this topic. So let's go. Hello, I'm Harshit Agrawal, second year computer science student at NIT Trichy. My roll number is 106118036. I'll be presenting on the topic Wi-Fi 6, the new age of Wi-Fi technology. So let's begin and unlock Wi-Fi 6. In this era of technology and connectivity, people want access to the internet just about everywhere. We have been using Wi-Fi for quite some time now, and it has evolved to provide greater speeds and better connectivity over the years, with Wi-Fi 6 being the latest upgrade. Before moving on to Wi-Fi 6, let's talk about what Wi-Fi exactly is. Wi-Fi, also known as wireless fidelity, is a wireless networking technology that allows devices such as computers and mobile devices and other equipments, printers and video cameras to interface with the internet. It is a family of wireless network protocols based on the IEEE 802.11 family of standards, which are commonly used for local area networking of devices and internet access. But Wi-Fi wasn't so advanced as it is now. It took years of research and hard work to reach the speeds that we currently have. Let's look at the brief history of the evolution of Wi-Fi. 1999, the first generation 802.11a standard and the second generation of 802.11b standard is released. This means that it was way back 21 years ago that the first proper Wi-Fi came into existence. Then, in 2003, third generation with faster speeds and distance coverage with the 8.2.11g standard came. It had speeds of about 54 Mbps and could listen to songs on a Walkman in a jiffy. 2009, fourth generation, which is the 802.11n standard, was released. Faster, had more antennas and could process multiple streams. This led to a huge jump in the speeds and the number of devices being used at a time in Wi-Fi. 2013 was the birth of the fifth generation of Wi-Fi, that is the 802.11ac standard, triple the previous speed, and it was the first time that the Wi-Fi broke the gigabit per second barrier. That means speeds greater than 1 Gbps were achieved. In 2015, the emergence of MU-MIMO standard took place, which was becoming the development into Wi-Fi 6. 2019 and the end of 2018 marked the beginning of Wi-Fi 6, the 802.11ax standard, called as Wi-Fi 6 because Wi-Fi Alliance, instead of having the confusing standard names, it decided to name all its previous generations, that is the 802.ac standard, as the Wi-Fi 4, 802 Wi-Fi 5 and 802.11n standard as the Wi-Fi 4. So 802.11ax standard became Wi-Fi 6. It could achieve massive speeds up to 9.6 gigabits per second. Let's talk about the current version of Wi-Fi and its features. The current version of Wi-Fi is Wi-Fi 5, which is the 802.11ac standard. It operates over the frequency of 5 GHz. It supports MIMO, which is called as multiple input and multiple output, which allows many devices to be connected to Wi-Fi at once. Theoretically, Wi-Fi 5 can reach up to speeds of 3.46 gigabits per second, which is a lot more higher than what Wi-Fi 4 could achieve. But practically, due to interference and multiple devices being connected, 1.733 gigabits per second is the maximum achieved speed. Now let's talk about Wi-Fi 6. Why Wi-Fi 6 was in demand is because people are having more and more number of Wi-Fi enabled devices and a faster internet was required. There was a lot of crowding and this led to a lot of problems with the internet connectivity. Wi-Fi 6 became the next generation standard in Wi-Fi technology. It operates over two channels, that is the 2.4 GHz channel and the 5 GHz channel that was used by Wi-Fi 5. Its maximum achievable speed is close to 10 gigabits per second, which is almost 4 times faster than the practical speed of Wi-Fi 5. Not just that, it also gives higher power efficiency, which is the need of the hour, given that power is everything. Now let's learn about some technologies that influence Wi-Fi 6. First one is MU-MIMO, which stands for Multiple User, Multiple Input, Multiple Output. What it's trying to say with all those multiples in there is that there is a protocol which allows multiple users to send data at the same time, up to 8 devices, but Qualcomm has gone a step further and it allows 12 devices to be transferring packets at the same time. Now, this doesn't mean that there will be only 8 devices that can be connected at a time. What it means is that every time Wi-Fi 6 sends out a packet of data, which it does a lot many times, then what can happen is that it can send it to 8 different devices each time. This means there can be tons of devices connected and 8 devices will receive the data at the same time, as opposed to single user MIMO, which could send data only to one device at a time. This means there will be a lot faster speed and efficiency involved. So this technology is available called as orthogonal frequency division multiple access. This means that each packet of data can contain data for more than one device. So it can be transmitted like a chain to the devices. So suppose there are 8 trucks given by MU-MIMO. Now each truck gets the data and it receives data in a segmented form, that is for separate number of devices, instead of occupying one truck for one device. What it does is it links devices like a chain or a spanning tree, as we consider in algorithms, and it transfers the data one by one without having to come back. Third one is target wake time. Now, target wake time allows the router to talk to each device and agree on how long the device should stay up and receive data and how long in between those times it should go to sleep. The router will only send data when the device is awake, so the sleeping devices would never get the data. This decreases congestion and also improves the battery life of the Wi-Fi 6 devices, because they only need to stay awake when they are receiving the data, and rest of the time they can simply stay off. As we talked about a few benefits, let's talk about a few more technologies involved. OFDMA can be visualized as a graph between frequency carriers and times. So different devices can receive their data in different blocks of frequency, instead of one block being occupied just for one device and wasting the time for other devices. Second one is the MU-MIMO, which means that multiple devices can receive the packet at once. Third one is the power efficiencies, which was achieved through target wake time. Fourth one comes up the BSS coloring. Now this one is maybe small but considered very crucial, because it helps in interlinking and increases the capacity of the network and increases the enhanced coexistence of Wi-Fi signals, because there might be many Wi-Fi signals at the same time. Not just that, Wi-Fi 6 now has longer OFDM signal, which means that there is outdoor reliability, not just inside the homes, and you can use the Wi-Fi outside also, and there is an increase in the peak throughput. This means that there is more number of data being sent per second of time. Now, Wi-Fi 5 had only 256 QAMs, but Wi-Fi 6 has 1024 QAM, which is a 25% increase consider as 8 bits of data take 256 forms and 10 bits of data means 1024 forms, which means more data is being sent at a single time. We have seen the technologies being used in Wi-Fi 6, but what makes Wi-Fi 6 special are the benefits that it provides. The first one is the increased capacity and data rate. With the increase in speeds, Wi-Fi 6 is bringing significant speed improvements. While it is not as big as the one we saw when we moved from Wi-Fi 4 to Wi-Fi 5, but it's still quite a lot. In the perfect Wi-Fi connectivity situations, users can see a theoretical 40% increase in connectivity speeds. The new standard achieves that by improving data encoding, resulting in higher throughput. It uses OFDMA technology that helps in splitting up the data and multiplying the speed by a lot great factor. Basically, Wi-Fi 6 devices will be able to pack more data in the same space spectrum, and this is made possible by the new chips which are much more powerful than the previous counterparts. Even though Wi-Fi 6 has not that huge speed gap, but what makes it better is that it is more efficient. Second one is the simultaneous multi-user support. Now, it allows Wi-Fi access to connect to multiple devices at that time. Before MIMO was a thing, a Wi-Fi access point would connect to one device at a time while other devices had to wait in line for a connection. Since the switch actually happens within microseconds, we users don't notice the switch, that is, till the number of devices is pretty small. But as soon as you increase the number of devices, you will see delayed responses and latency and dropping in connections. But MU-MIMO provides multiple user support, and Wi-Fi 6 Wi-Fi 6 improves upon this and increases from 4 to 8 devices. The new Wi-Fi 6 standard will allow both downlink and uplink connection. The third one is improved power efficiency. Now, power is an essential factor in anything, so the target wake time is an awesome feature which is great for battery life on our mobile devices. When the same access point is accessed, then there is no need to wait for a longer time, and instead of that, if they wait for a longer time, there will be a huge draining battery. With Wi-Fi 6 standard, the access point will be able to tell devices in line the exact time they will receive the connection so they can stay asleep till they are accessed. Fourth one is performance in hyperdense environments. Now, this is achieved by the dual channel method being used in Wi-Fi 6. The new Wi-Fi 6 standard will operate in both 2.4 GHz and 5 GHz channel. This means that you will have the advantage of not only having long-range connectivity but also higher data throughput. Some tech companies like Apple and Facebook are also lobbying for the release of 6 GHz bandwidth for Wi-Fi usage. If that happens, then this will release never before used channels, resulting in lesser congestion and better performance in hyperdense environment. Now let's talk about the use cases of Wi-Fi 6. Wi-Fi 6 can be used for application assurance, which means that you will be assured that there will be lesser congestion and there will be more reliability over the things that are going through the network. Moreover, we can have in-building wireless coverage. That means that the whole building can be Wi-Fi enabled and you don't need to have any wired connection in the network. So that means that anywhere in the building people can work, which can lead to a greater efficiency. Edge computing is the technology of the future, and with Wi-Fi 6, intelligent edge computing and IoT devices can be manufactured and be used at home. IoT devices use a 2.4 GHz channel, so with Wi-Fi 6 introducing a 2.4 GHz channel, there will be more IoT convergence. And with the WPA3 security coming through instead of the WPA2, Wi-Fi 6 devices compulsorily need WPA3 to function, which has greater security and benefits. Not just that, smart classrooms, augmented reality, virtual reality, and a lot of other features of the future are the ones that Wi-Fi 6 can give greater reliability to. Now let's talk about the hardware that supports Wi-Fi 6. Wi-Fi 6 is not just a software update. You can't update your Wi-Fi 5 router just by going for a software update. It's a hardware and a software improvement. So a new router and a new device that can support Wi-Fi 6 is required, even though Wi-Fi 6 supports the downplayed Wi-Fi 5 devices also. So you can see that we have TP-Link Archer AX6000, Asus ROG Capture GT AX11000, Netgear Orbi RBK852, and the Netgear Nighthawk AX12 RAX120. These are some of the greatest Wi-Fi 6 devices, routers that are in the market right now and offer an enormous speed. Wi-Fi 6 was something that began in 2019 and it's accelerating. The first Wi-Fi 6 device was the Samsung Galaxy S10, which was released in February 2019, and that led to the release of a few more routers called the CN115AX, CN117AX, and the CN120AX. Due to the boom in Wi-Fi 6, even laptops powered by Intel that are HP and Dell were released in mid-June to July 2019. Samsung Galaxy Note 10, Apple iPhone 5, and Microsoft Surface Pro laptops are now Wi-Fi 6 enabled. Wi-Fi 6 has a lot more to offer, and it's just the beginning, with Wi-Fi 7 talks to be released in 2023 still going on. This means that by the year 2025, almost all the devices will be Wi-Fi 6 enabled. So let's see what the future holds and move on to a greater technological world. Thank you.